Alright, welcome to today's class. Let's look at the physics test question for 2024/2025 session. Certain topics we are considered. We have the universal gravitation, we have the simple harmonic motion, circular motion, vectors, and dimensional analysis. Let's look at the question. This is Physics 101/105 test, first semester 2024/2025 academic session. The time allowed is 1 hour. And then instruction, attempt all questions. It says attempt all questions. We have about 3 questions here. But in this class, we are going to solve only one. Then in our next class, we will solve the remaining. Let's solve the third question. It says, are real machines 100% efficient? Why? Are real machines 100% efficient? Why? Alright, this is the answer. 3A. Real/actual machines have efficiency less than 100% because part of the energy supplied is used in doing work against friction and in moving parts of the machine. So real machines are not 100% efficient. Reason being that part of the energy supplied is used in doing work against friction and in moving parts of the machine, or in doing some other work. Alright, so we've answered 3AI. Let's look at 3AII. We have relative to their nature. How is circular motion different from rotational motion? How is circular motion different from rotational motion? So we are asked to differentiate between circular motion and rotational motion. Alright, it says a body is said to undergo circular motion when it moves in a circular path without a fixed axis of rotation, while in rotational motion, the body moves in a circular path with a fixed axis of rotation. So in circular motion, there is no fixed axis of rotation, but in rotational motion, there is always a fixed axis of rotation. Let's take an example. Alright, so this is a picture of the Earth revolving around the Sun. You can see that the Earth revolves around the Sun. There is no fixed axis for the Earth, but it revolves around the Sun. So this is called a circular motion. Alright, so here we have a fan. The fan is fixed at a point, but the blades move in a circular path. So this is called a rotational motion. Remember, rotational motion has a fixed axis and moves in a circular path, but circular motion does not have a fixed axis, but it moves in a circular path. Alright, so let's look at the next question. That's 3BI. If you move at a single point from the Earth's surface to an altitude of 160 km, what would be the difference in the acceleration due to gravity that will be experienced? mass of the earth mth is equal to 5.28 exponent 24 or 5.28 times 10 raised to the power 24 kg. And then the radius of the earth rth is equal to 6370 kilometer. And finally, gravitational constant G is equal to 6.67 times 10 raised to the power negative 11 Newton meter square per kilogram square. So in this question, we are asked to find the difference in the acceleration due to gravity. It says what would be the difference in the acceleration due to gravity. Alright, so before we continue, if you've not subscribed to this channel, kindly subscribe now. If you've not subscribed to this channel, please subscribe now. You can also like this video, and if you have a question, endeavor to leave your question in the comment section of this video. Alright, so from the question, we are given that the altitude let's call it h is equal to, let's confirm. This is the question. It says if you move at a single point from the Earth's surface to an altitude of 160 kilometers. So our altitude is 160 kilometers. Alright, so we are going to convert from kilometer to meter. And to convert from kilometer to meter, you simply multiply by 1000. Equal to 1.60 multiplied by, we have here 10 raised to the power 5 and then meter. Alright, so what's the next parameter given? It says what would be the difference in the acceleration due to gravity that you will experience. The mass of the earth mth is equal to 5.28 multiplied by 10 raised to the power 24 kg. So we have mass of the earth mth mth is equal to, we have here 5.28 multiplied by 10 raised to the power 24 kg. Alright, so what's the next parameter given? We are given that the radius of the earth rth is equal to 6370 kilometer. So we have the radius of the earth is equal to Now, some textbooks call it radius of the earth, while others call it distance from the center of the earth. So it's either you use the radius of the earth or distance from the center of the earth. So it is equal to what? Let's confirm. So 6370 kilometer. We have 6370 kilometer. Now we are going to convert from kilometer to meter. And to convert from kilometer to meter, you simply multiply by 1000. So therefore, our earth is equal to 6.37 multiplied by 10 raised to power 6 and then meter. Alright, the next parameter given is the gravitational constant G. It is given as 6.67 multiplied by 10 raised to power negative 11 Newton meter square per kilogram square. So we have here gravitational constant. Gravitational constant, capital letter G, is equal to 6.67 multiplied by 10 raised to power negative 11 and then the units. Alright, so these are all the parameters given in the question. We are given the altitude, which is h. We are given the mass of the earth. We are also given the radius of the earth. And we are given the gravitational constant, which is capital letter G. The gravitational constant, capital letter G. Alright, note this. At surface level, of the earth, acceleration due to gravity G is equal to gravitational constant multiplied by the mass of the earth all over the radius of the earth raised to power 2. So at surface level, acceleration due to gravity is equal to gravitational constant multiplied by the mass of the earth and then all divided by the radius of the earth raised to power 2. So we can now substitute the parameters into this equation. We have that G is equal to, what's the gravitational constant? Gravitational constant is 6.67 multiplied by 10 raised to power negative 11. And then multiply by, what's the mass of the earth? The mass of the earth is 5.28 multiplied by 10 raised to power 24. All right, so they are all divided by the radius of the earth raised to power 2. So what's the radius? The radius is 6.37 multiplied by 10 raised to power 6, and then all raised to power 2. All right, so 6.67 multiplied by 10 raised to power negative 11 multiplied by 5.28 multiplied by 10 raised to power 24. It gives us 3.52176. And then multiply by 10 raised to power 14. Divided by 6.37 multiplied by 10 raised to power 6 all raised to power 2. If you punch your calculator, it will give you 4.05769, and then multiply by 10 raised to power what? 10 raised to power 13. All right, so 3.52176 multiplied by 10 raised to power 14 divided by 4.05769 multiplied by 10 raised to power 13 gives us 8.679. It gives us 8.679. Therefore, the acceleration due to gravity at surface level, let's call this G1. Let's call it G1. The acceleration due to gravity at surface level is equal to 8.679 meter per second square. 8.679 meter per second square. All right, let me show you how we got the meter per second square. Now remember that G, which is acceleration due to gravity at surface level, is equal to gravitational constant multiplied by the mass of the earth divided by the radius of the earth raised to power 2. So it is equal to, all right, so if you write the unit for each of the parameters given, you will have Newton meter square, and then kg raised to power negative 2 multiplied by the mass of the earth is measured in kg, and then all over the radius of the earth is measured in what? It is measured in meter. And remember that radius is raised to power 2, so we have m raised to power 2. So here m raised to power 2 cancels off m raised to power 2, and then kg cancels one of the kg. Kg cancels one of the kg. So we are left with kg raised to power negative 1. So therefore G is equal to Newton per kg. Newton per kg. Now, recall that Newton one Newton is equal to kilogram meter per second square. 1 Newton is equal to kilogram meter per second square. So if we substitute this into G, we would have G is equal to kilogram meter per second squared multiplied by per kg. So this can be written as G is equal to kg and then meter all over kg and then second square. So kg cancels off kg. So therefore, acceleration due to gravity G is equal to meter per second square. So that's how we got meter per second square here. So G1 is equal to 8.679 meter per second square. All right. At a given height, or altitude, acceleration due to gravity G is equal to gravitational constant capital letter G multiplied by the mass of the earth mth all over the radius of the earth r plus the height of the altitude, and then all raised to power 2. All right, so let's substitute into this equation. We have that G is equal to, what's the gravitational constant? It is 6.67 multiplied by 10 raised to power negative 11. And then multiplied by, what's the mass of the earth? It is 5.28 multiplied by 10 raised to power 24. And then all over what's the radius of the earth? It is 6.370 rather, multiplied by 10 raised to power 6. And then what's the height of the altitude given? The height of the altitude given is 1.60 multiplied by 10 raised to power 5. Close your brackets, all raised to power what? 2. All right, so 6.67 multiplied by 10 raised to power negative 11 multiplied by 5.28 multiplied by 10 raised to power 24. It would give us, if you punch your calculator, it would give you 3.521 and then 76 multiplied by 10 raised to power 14. all over, we have here 4.26409 multiplied by 10 raised to power 13. Alright, you can also punch your calculator to confirm all these values. Kindly punch your calculator to confirm all the values. G is equal to, if you divide through, it will give you 8.259. And remember, acceleration due to gravity is measured in meter per second square. Acceleration due to gravity is measured in meter per second square. So let's call this G2. Remember, we called the first one G1. Let's look at the question again. In the question, we are asked to find the difference between the acceleration due to gravity. We said the difference in the acceleration due to gravity. So we have two acceleration due to gravity already. We have the G1 and the G2. So to find the difference, we are going to subtract one from the other. So since G1 is equal to 8.679, measured in meter per second square, and then G2 is equal to 8.259, measured in meter per second square. Therefore, the difference between the acceleration due to gravity is G1 minus G2. So which gives us G1 minus G2 is 8.679 minus 8.259. So the difference is, can you punch your calculator? 8.679 minus 8.259. So our answer becomes 0.42 and then measured in meter per second square. So this is our final answer. The difference between the acceleration due to gravity, or the difference in acceleration due to gravity, is 0.42 meter per second square. All right, let's solve the last question here. That's question 3bii. If you initiate the simple harmonic motion of an object, causing it to go through 2 complete circles in 1.0 second, what would be the period t, frequency f, and angular frequency of the object? So we are asked to find the period t, the frequency, and angular frequency of the object. Alright, in the question, we are told that the body goes through 2 complete circles. We are told that the body goes through 2 complete circles in 1 second. So the body goes through 2 complete circles in 1 second. And now we are asked to find the period we are asked to find the period T. Remember, period T is equal to 1 all over the frequency. Period is equal to 1 all over the frequency. Where frequency F is the number of circles. Frequency is the number of circles. So in the question, we are told that the body goes through 2 complete circles in 1 second. So therefore, the frequency is equal to 2 circles. The frequency is equal to 2 circles. Now let's substitute F into this equation. Period T is equal to 1 divided by 2. So therefore T is equal to 0.5 seconds. Remember, period is measured in seconds. Alright, so this is the value of period. Since T is equal to 1 all over F, if you make F the subject formula, F will be equal to 1 all over T. So if you substitute into this equation, you have 1 divided by, the value of T is 0.5. So kindly punch your calculator. 1 divided by 0.5, it would give you 2. So therefore, frequency F is still equal to 2. So the unit of frequency, it's either per seconds or frequency is equal to 2 hertz. Frequency is equal to 2 hertz. Alright, in the question we are asked to find the angular frequency of the object. That's the final question. Angular frequency is equal to 2 pi multiplied by F. Angular frequency is equal to 2 pi multiplied by F. So we can now substitute into this equation. So it is equal to 2 multiplied by, what's the value of pi? Pi is 3.14. And then multiply by, the value of frequency is 2. Alright, kindly punch your calculator. 2 multiplied by 3.14 multiplied by 2. So therefore, angular frequency is equal to 12.56 radians per seconds. So this is our final answer. Alright, kindly check the description of this video and you will see the link to other related videos. If you've not subscribed, kindly subscribe now, and if you have a question, ensure you leave your question in the comment section of this video. See you in our next class.